Hello everyone, I'm Aaron from DataStax, and today I'm going to talk to you again about migrating an enterprise e-commerce website from Spring Boot Spring Data over to the DataStax Table API. Today, in this part, we're going to focus on the pricing subsystem and the things that we need to change in order to go ahead and, make those pricing calls happen through the Table API. All right, let's go. So, this is our e-commerce website that, this is the platform that we built up for that workshop. If I have a look, maybe one of these products here, there we go. You can see it comes up just fine. In this case, it actually is doing a product query that is calling that same table in Astra using the Table API. So I can go ahead and I say large, I can add that to my cart. And oh, hey, this goes ahead and trips the product recommendation logic that says, hey, if you like this DataStax Astra one team long sleeve shirt, you may also like this DataStax gray track jacket. Pretty cool, huh? Anyway, let's go ahead and have a look at Astra for a second here. Click on my vector database. And you can go to our Data Explorer. Now you see I'm in my e-commerce key space, but I don't have any collections available. That's because every structure that's under my e-commerce key space, as you know, if you attended those workshops a few years ago, they're all CQL tables. And since our Data Explorer in Astra only works with collections, which are a special kind of CQL table, they don't actually show up here. So we need to go into our CQL console. All right, so let's do a use e-commerce and desk tables. Yep, you can see we have all those tables as a part of our e-commerce platform here. So let's go ahead and do a select star from product. And as you can see, yep, we have 35 product rows out here. So if I go back here, I can have a look at the cart because I've added it out here. You can see it's out here. If I look in here, here we go. DataStax Astra one team long sleeve tee medium. All the different sizes are out here actually. So yeah, given out at our internal summit a few years ago. So yep, that's definitely out there in the database. And as you can see, this is a CQL table for sure. So now let's talk about price, because price is something that we're going to look at moving over as a part of this video. So how about we say select star from price? Oh, not prints, price, and we can say, how about we say DSH 915? There we go. Product ID is, oh right, we need a size on there. Let's say XL. There we go. How about select star from product? Let's make sure we're looking at the right one here, where product ID equals XL. Okay, let's try DSA 1121. There we go. There's our DataStax one team long sleeve tee. Now let's go ahead and select from price DSA 1121 XL. There you see, we can sell it for $21.99. All right. So, and again, as you can see, this is a CQL table. Let's go have a look at converting these pricing calls from a Spring Data Cassandra CQL call to a DataStax Data API Table API call. Let's give that a shot. So let me start by stopping that. Okay, if I have a look at the price REST controller here, let's see. So we have our price repository. Yep, and then we inject it using the Spring framework. Here we have price by ID. Yep, find by product ID in store. Down here that we have a mapper for it. Okay, so this is a pretty simple class. So let's go ahead and start by getting rid of our price repository object. Let's have a look at the product REST controller just to verify a little about how we did that. And you can see that we need our declaration of our Data API Services class property. So let's grab that. And we're just going to go ahead and paste that right there. Now what we're going to do is kind of grab this Data API Services object. We're going to go ahead and paste that. And then let's say Data API Services equals, or this .data API Services equals our, we'll just say Data API repo. How about that? We were giving it a halfway decent name. Okay, so we have that injected. No problem. All right, so let's go down here a little bit. Okay, so of course it's having a little bit of a problem here with our find by key product ID because, well, that doesn't exist anymore. So let's say, now, before we can do that, we actually need to create an entity class here, and we do not have one at the moment. Now you can see that we've created things like, the product table entity and the featured table entity. So let's go ahead and say new class, and we're going to say this is the price table entity, just like that. And we're going to make sure this ends up in the Data API entities package. So let's do finish on that. All right, so the first thing we're going to do here is, oh, look at that. Copilot was actually kind of close on here. We really do want this entity table annotation, but if we remember right, the name of the table is just price. So let's do that. And then let's hover over and make sure we bring in that mapping from com DataStax Astra client tables mapping. There we go. Outstanding. So we have our price table entity. Now we have a few things out here that we need to consider. And specifically, if I say, go back to Astra here and say desk table price, we have 3 columns we need to be concerned about out here. Number 1 is the product ID, which is our partition key. Next is store ID, which is our clustering column, and then our payload column value, which is a decimal. So let's go back to here and let's start with product ID. So first things first, this is our partition key. Partition by 0. So that 0 is specifying the ordinal position in the primary key. And then let's do column, and we'll say name equals product ID, and that should be enough. And then private string product ID. Perfect. Now let's bring in partition by from that mapping library, and then column is going to give us a couple of options here. Now we don't want the one from the Spring framework. We want the one again from that Astra client tables mapping library. There we go. Perfect. Okay, now the next one we had was the store ID, because when you think about working for a large e-commerce organization, you may have brick and mortar stores. Those stores will likely be in different geographic areas, and they will also likely have different prices associated with the same products. Likewise, you may also have a special price for the web, which is what we're using here, because all of our, if you remember from my query back here in Astra, you can see that we have a store ID of web for that product out there. So that is the store that we're actively using here. So let's go ahead and say partition sort. And we want ordinal number 1. So for this one, we actually have to specify. Let's say position equals 1. We're going to say order equals sort order. It says descending as a default, but if you look here in our clustering order by, we do cluster on store ID ascending. So we're actually going to switch that to ASC for ascending. I think we have to spell it out. There. Oh, and we don't need a, right. Column name equals store ID. There we go. And then we also want private string store ID, just like that. Okay, now the rest of this will resolve. We can highlight here and say, yep, import partition sort, and then we can highlight over here and say, yep, bring in sort order so we get that enum to resolve. And all right, now we're good. So now we have our key defined. Let's go ahead and have a look at, yep, we just need a column. Its name is price. And let's see, I believe the decimal type inside of Cassandra and Astra maps to a big decimal. So let's say private big decimal price, just like that. All right, so let's hover over here and import big decimal. And then we're also going to need some public assessor methods. So in the middle here, let's just click source, generate getters and setters, select all, and generate. There. Okay, this should do it for our price table entity. So we have that created. Okay, so now with that entity created, let's go back to our price REST controller here. And we can say list price table entity. And sure, we can just say E equals data API services. Find all prices by product ID. Does that actually exist? No, it does not. So let's go ahead and have a look at our data API services here. And if we scroll to the bottom, let's go ahead and say public list price table entity, and we'll say get all prices by product ID. That'll be with a string of product ID. And actually, one little modification I need to make here is that the column is actually named value. So let's do that. Let's go ahead and adjust that throughout here. There. Okay, now we have updated that accordingly. Right, so we're back at this table data API services. Let's go ahead and import the price table entity in there. And if we have a look up here, oh, I have not created one yet. So let's go ahead and do auto-wired qualifier table.price. And we're going to say table price table entity, and this is the price repository. We also need to have a matching definition in our data API config here as well. So there we go. Let's say bean table.price, and this is going to be, yep, Copilot is right on the money this time. So let's go ahead and pull in that price table entity. Yep, table exists, price. Table price does not exist, creating it. Yep, this all looks good. All right. So if we go back to here, get all prices by product ID, this then works. Back to our REST controller, let's just do get all prices by product ID, and let's pull in a reference. Let's pull in the price table entity for library. Okay, and this works with the exception of our mapper down here. So let's go ahead, yeah, map price. So let's go ahead and say price table entity, and this is just going to be get product ID. This becomes get store ID. There. Okay, now our mapper is okay. All right, so this find all products, or find all by product ID should be okay. Let's move on to here. So really, what this one is doing here is calling with a store ID. And for this one, it's just, we're just worried about the web. So we're going to do a find by product ID and store ID, which is really this next one here. So this is the next one that we need to worry about. So for starters, we're going to have the price table entity be our new product entity. And let's get rid of that. And we're going to say data API services, find price by product ID and store ID. So we can just do that. Okay, now it's probably complaining here because that doesn't exist yet. So of course, let's bounce back to our data API service here. And we're going to create another one. This is going to be public optional price table entity. So if we delete that and we have our get price by product ID and store ID. So what we're going to do is say filter, and we're just going to call it filter, no creativity there. And we'll say new filter, and we want to do map of, and we're going to say, yeah, that time it looks like it got them right. There we go. Map of product ID, store ID, store ID. I think that'll work okay. And now we can say return, yeah, price repository, find one. Oh, and let's make that filter and save that. And that should be okay. All right. Let's give this a shot here. Okay, that's running. Now let's go check the site. Back to the beginning here. All right, maybe refresh. And hey, look at that. And we're getting pricing back with our products. So that's good. Now let's add that to the cart. Okay, outstanding. Oh, it says we might like the 2015 MVP hoodie. Very nice. All right, take a look at the cart. Okay, yep, we've got our one team shirt in there from before. Our DataStax black hoodie. Okay, hey, this is working. Okay, so with that, we've successfully converted the pricing subsystem of product over to use the table API instead. So, all right, everyone, thanks for joining me again in this video and, watching me convert another enterprise e-commerce subsystem over to use the table API. As always, if you want to check out the code yourself, it's available out on the GitHub repository, so feel free to have a look. Thank you and have a great day. Want more information on modernizing your self-managed Cassandra deployments? Head on out to datastax.com/modernize-apache-cassandra-workloads, and you'll find all the information you need on keeping your self-managed Cassandra cluster updated and in top running form. Thank you and have a great day.